So in this video, we're going to talk about how to sum up the forces from free body diagrams. So let's say we have a situation where we have a piece of paper falling through the air with a constant velocity. So if we were to draw the free body diagram of that, just draw some box, and then the paper has a weight, which is the force of gravity, of 2 newtons. Gravity goes straight down, so that's 2 newtons. And it's acted on by an air resistance of 2 newtons as well. And air resistance is going to be acting from the bottom of it, so it's going to be holding it up. F air. And that's also of 2 newtons. Now, when we sum up these forces, you're going to sum the forces in the x direction and then sum the forces in the y direction. And you do those two things separately. Here, we don't have any forces in the x direction. And so all we have is the sum of forces in the y direction. This little is sigma. It's the Greek letter sigma. And it just means the sum of. So the sum of the forces in the y direction acting on this piece of paper. So air is in the up direction. So we'll call that one positive. And the force of gravity is going down. So we're going to subtract that because they're in opposite directions. And these two are balanced. Even though it's moving with a constant velocity, it has no acceleration because it has a constant velocity. So these two are balanced, and so they should equal 0. And you see that 2 newtons minus 2 newtons does equal 0. So this would be summing the forces here for this particular object. So in this situation, we have a book being pushed across a table at a constant velocity. Now again, just like with our piece of paper, if it has a constant velocity, that means all of its forces have to be balanced, which means that the forces in the x direction have to sum up to 0, and the forces in the y direction also have to sum to 0. So the book is being pushed across the table with a constant velocity. It has a weight force of 25 newtons, and it has a rightward force of 15 newtons. So F applied is 15 newtons. Now, we know it's moving at a constant velocity, and we also know that it's not falling through the table. So there have to be other forces that are balancing this out. So the force that's balancing out the weight that's keeping it from falling through the table is called the normal force. And that comes from the surface of the table. And we'll talk more about normal force later, but if the book isn't floating into the air or falling through the table, then these two forces have to be balanced and they have to sum to 0. So this also needs to be 25 newtons. If it's moving at a constant velocity, it has no acceleration, which again means that these two, or this force, has to be balanced with something else. Well, if you think about it, if you're pushing a book across the table, what's the other force that's acting on the book? It doesn't say it up here, but there has to be friction acting against this. And since it's a constant velocity, they have to sum to 0. So that means that this force of friction also has to be 15 newtons. And so I'm going to sum my forces in the x direction separately from my y direction. So the sum of the forces in the x direction, I have 15 newtons, so I have that F applied, and then the friction is going in the other direction, so it'll be subtracted from it. And we know that these are balanced, so they have to equal 0. And so that F applied is 15 newtons minus my force of friction, which is also 15 newtons, and that equals to 0. In the y direction, to sum my forces, I have this normal force going up, balancing out my weight force going down. So my Fn minus my Fg, force of gravity, has to equal 0. 25 newtons minus 25 newtons is equal to 0. So in this example, we have a book being pushed across the table with a rightward force of 30 newtons, and it has a weight force of 35 newtons. If the net force in the right direction is 25 newtons, then sum the forces. So this one makes you think a little bit more. If the net force in the right direction is 25 newtons, that means there has to be something working against it, some force of friction. And then again, it's not going through the table, so that normal force from the surface of the table is going to balance this out. So if we sum these forces, the sum of the forces in the x direction is going to be the applied force minus the force of friction, and we know that that equals 25 newtons. The applied force is 30 newtons. They're going to equal 25 newtons, and so 30 minus 5 is going to be 25. And so that force of friction is going to be 5 newtons. If I sum the forces in the y direction, then I have my normal force minus my force of gravity. They're balanced, so they'll equal 0. And again, you can see that that 35 newtons minus 35 newtons is going to equal 0. Now in this x direction, since you have an unbalanced force, it will equal mass times acceleration, and we will talk about that later.